So here we have the latest bit of pick wizardry from my mate Phil G. He's designed and built a pulsar for the old Adams style magnetic actuators. It's not Galloping Ghost, it's a more rudimentary form. And it's driven by the rudder or the aileron channel of a conventional propo set. Connects inline, there's the blob of electronics. So what it essentially does is fool the receiver into thinking that this is a standard proportional servo. The pulsar comprises of just two chips. They're in a 16-pin socket, so it's small, weighs 5 or 6 grams. It's got a full bridge output, so it drives the magnetic actuator in both directions. As you can see, you'll see this in more detail when we power it up, at 7 cycles per second, just like the old pulse proportional sets. Proportional output from the receiver precisely controls the mark space ratio, with the mark driving it one way and the space driving it the other. These are the essential components of how Galloping Ghost works. And the rudder clacks away just like the old sets of old. So we'll power it up now and see it in action. There you go. Now then, as you can see, bring the transmitter into shot. As push stick to the right, it biases it to the right, pushes it to the left, biases it to the left, and in between the position is the average of the travel. This will make more sense when I put it in the model, which I shall do now. Point of note, you see it's on a sliding rail system. This was very popular because radio gear was expensive back in the day and not many people could afford multiple sets of kit, so what they did is they made it easily transportable from model to model, and this was a simple way of doing it. Even motorised actuators were fitted onto trays. Dave Boddington was the chap who used to favour that. This model actually belonged to Dave Boddington and it was built originally by Arthur Fox. So there you go, see it flapping away furiously. And again, transmitter in shot, as you can see. Right rudder biases it to the right, left rudder to the left, and in between you can see what happens is, although it's flapping, the average of the position is the path that the aircraft follows. They did need designing a little differently to a traditional model, but they worked well. They were inexpensive and they gave you a form of proportional flight. There we go.